Okay, ladies and gentlemen, let's take a look at number 51. Now, this is actually, I'm going to call it part 3, but it's actually part 4 because I named part 3 part 4, and I can't do the thing without changing the whole thing. At any rate, the point is we want one trig function, which means I need to take tan, cosecant, and secant, get rid of all that, and get it in terms of one trig function. And I've already written my problem wrong because that's a times. Now, if I were going to all the same trig function, I would think the easiest thing to do in the world, change everything to sines and cosines, mainly because I know my sine and cosine identities the best. So let's go sine x over cosine x minus, let's see here, that would be 1 over, and cosecant goes down as sine x, secant is cosecant x, or cosine x, sorry. So that turns into this by reciprocal property and quotient property. Now, in this case, I still have two fractions. What do I do every time I have two fractions, ladies and gentlemen? Every time you have two fractions of these, you're going to find common denominators to put them together. So I have sine and a cosine. This needs a sine x. This needs a sine x. So I have sine squared x over sine x cosine x minus 1 over sine x cosine x, and that is by common denominators. And so let's put them together. I got sine squared x minus 1 over sine x cosine x, and that's nice. Ooh, 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 sine squared x minus 1, yay. No, because sine squared x plus cosine squared x equals 1. If I move the sign across, it's cosine squared x equals 1 minus sine squared x. It's backwards. How do we deal with backwards? -1. So you get -1 over times 1 minus sine squared x over sine x cosine x. What is 1 minus sine squared x? 1 minus sine squared x is cosine squared, so negative cosine squared x over sine x cosine x by Pythagorean. And wait a minute, cosine top, cosine bottom, one gone, one gone. I'm left with negative cosine x over sine x. What is cosine over sine but negative tan x? And now by quotient property, this one was reduced. Okay. Do I have everything in terms of a single trig function? Yes. That's what we need to do. So by putting in terms of a single trig function, we're done.